Welcome back. In part 1, we fixed the first 5 assembler errors by following a simple debugging process. We'll continue using exactly the same approach. Let's build the project again. The first error now is bad shift name. At first glance, this instruction appears to have 4 registers. Why would assembler complain about a shift? To answer that, let's first recall the syntax of the add instruction. Here, operand 2 can be a register, an immediate value, or a shifted register. For example, add R0, R1, R2 or add R0, R1, R2, LSL #2. After reading this particular instruction, the assembler considers the instruction complete. However, it then encounters another comma followed by R4. At this point, ARM assembler assumes that whatever follows the comma should be a shift operation, such as LSL, LSR, ASR, or ROR. Instead, it finds another register name. Since R4 is not a valid shift type, the assembler reports bad shift name. Now, let us remove the extra register and rebuild the project. You can see that particular error has now disappeared. The next error we notice is unexpected characters at end of line. Let's understand what ARM assembler is trying to do. The assembler reads every line from left to right. Whenever it encounters a line, it expects one of the following: a label, instruction, assembler directive, or valid comment. Most programming languages such as C, C++, Java, JavaScript uses this symbol to begin a comment. Many beginners naturally assume ARM assembly works the same way. Unfortunately, ARM assembler uses a different syntax. In ARM assembler, comments must begin with a semicolon. Since the slash is not valid in this context, ARM assembler reaches the end of the line without finding anything meaningful and reports unexpected characters at end of line. The assembler is actually trying to say, I don't know what these extra characters mean. The fix is simple: replace slash characters with semicolon, or simply delete the line if the comment isn't required. Let's rebuild the project. Missing and directive at the end of file. Assembler directives must be spelled exactly as defined. The directive that marks the end of ARM assembler source file is end. So now when I rebuild the project, I can see missing and directive at end of file but found a label named end. That is because a white space is expected here. Now when I rebuild the project, that particular message disappears. The next error is undefined symbol loop1. The instruction means branch to the label loop1 if the zero flag is clear. The assembler now searches the program for a label named loop1. However, our code only contains loop. There is no label named loop1. Without a destination label, ARM assembler cannot calculate the branch address. Hence, it reports undefined symbol loop1. So replace loop1 with loop because that was our actual destination. And now when I save and build this project, there is only one warning appearing here which says added 3 bytes of padding at address hexadecimal 29, and it is pointing at this particular line. Let's understand why. Look at these definitions: array DCB10 and array1 DCD 20, 30, 40, 50. The directive DCB stores 1 byte. Suppose that byte occupies address 34. The next available address would become 35. However, DCD stores 32-bit word. A word should begin at an address that is multiple of 4. Address 35 is not word aligned. So ARM assembler automatically inserts 3 unused bytes before placing array 1. It reports this using the warning added 3 bytes of padding. Instead of allowing ARM assembler to insert the padding automatically, we can explicitly request alignment by using the align assembler directive. something like this. Now the program builds successfully. There are no assembler errors. There are no warnings. At this point, many beginners assume the program is completely correct. But that's not true. A successful build only tells us that the assembler understands the program. It does not guarantee that the program will execute correctly. In the next part, we'll switch from assembler debugging to runtime debugging and finally obtain a fully working code that correctly computes the sum of the array and stores the result in memory.